This is the second video on my series on the 2" by 72" belt grinder. Again, on the screen there, I've put Schmidt's website. It's his plans that we use to make this belt grinder. And in this video, we're going to be welding everything together. We had a few hurdles that we had to jump over, where we did things a little differently. We had to figure out how to make the inside diameter of a pipe bigger and things like that. So I hope that you'll find this useful, and at the end I'll wrap things up and give you my thoughts.
Longer tube.
So we are driving the tool post arm out of the sleeve that we are making up. We tried it with a hammer, and this proved to be a much more effective method. Always weld to the tack. That way you are not burning the tack away before the new weld has solidified. As you can see here, we've ground back the mill scale at the edge of the piece of steel where we will be welding, so the weld will be a nicer weld. All right, it's day 4. We've started to do some welding. It was actually yesterday on day 3. We're now setting up to weld some of the pieces together with the tubes that we've welded up yesterday.
And this is out of order from the original instruction.
So we're welding this portion of the grinder before we put it on the legs, even though the plans say to put it on the legs first, because we found, or we believe, that it's going to be easier to index it to the table than it would be if it were up in space. So here, this is just one of the other components that we've cut out for the rest of the grinder, and we're just putting it in there for a spacer so that when we weld things up, it can't pinch in on itself. We got some aluminum pop can, soda can shims in there, just to give us some wiggle room so that everything works smoothly when we're done. Over here, we're going to do the same thing, put this same shim here in there before we start welding over in this area, but we'll get everything positioned right where we need it to be, and we'll tack it over here, and then we'll get this positioned exactly where it needs to be there.
I can get to the back sides of these, so I'm going to go ahead and do those as well. You know what I'm saying? Yep. Before we take anything apart, anything I can get to, I want to hit. So that means I can hit this one here as well, and that one there as well. So let me do all that. Wrapped it a little. The other thing is wrapping it. It's going to pull that out, so it'll, and the same thing here, it'll pull it the other way if anything. So I'm not worried about it moving too badly.
My welding here is a little bit intermittent simply because the steel seemed to be getting a little hot, and this is a technique you can use to prevent from burning through the steel.
So we're in day 5, and Tom has worked on his a little bit. He welded this piece on. I've got to do that. That's what I'm doing right now. We've gotten to this point. This is the motor mount. And I am about ready to weld that piece right there.
You will see various pieces of steel stacked up and clamps every which way. This is simply to hold everything in place while we're welding. The steel wants to move when you start applying that heat to it, and this will keep it where it needs to be.
Sounded really good.
So this hole here has to take a 1/2 inch bolt, and it's slightly undersized, so we're going to use a reamer and make it exactly 1/2 inch.
Correct. This is a chucking reamer, even though I've got it in a tap handle. That way you can have some leverage on it without hurting the reamer. Big thing is you really want to kind of get it to start straight. It's like a regular tap. You want to kind of...
And you do not back this out, right?
Yeah, you never go backwards.
Only...
You want your cutting teeth to always be going forward. It'll kind of self go.
So this steel is cold rolled steel, so generally it's pretty accurate, but this I guess was a touch smaller than what we're shooting for. So
small enough that the bolt wouldn't go in cleanly. I can feel it cutting.
And this is more accurate than using a 1/2 inch drill bit. It'd catch pretty bad too, wouldn't it?
Yeah, 1/2 inch drill bit could wobble, and I mean, unless you put that piece. The reason we didn't do this before in a lathe is because the smaller size actually helped us index this piece with the spacers. Right. So now we can take it out to the final size, and so that that piece, the bolt, fits through there.
How much does a reamer cost?
Cheap ones are less than 20 bucks. Good ones are over 100. And if it's carbide or there's so many piloted, there's so many different options. This one's probably about $50, $60 reamer.
We're almost there.
Do a little test run. It's not ready to grind really, but it's running. Got the belt tracking properly. You still have to put the patent in there and then build the tool rest. Obviously we have some work to do on the motor, the used motor, so it is what it is, but we'll come up with probably a different switch situation there. Need them to clear the wheels right there.
It would be a good idea to remove your machinist square from the area before you start welding to keep the spatter off it.
All right, it's day 6 of our grinder build, and things are going well.
So I'm gonna go ahead and show you where we are.
That blue box there, that's just a switch box. That's going to be gone. We'll probably at some point put the switch up there.
The grinder is pretty much done. All we have to do is finish the tool rest.
And it works really well to this point. I'm very encouraged.
I liked working with these switch magnet clamps a lot better than the standard magnets because you could position them right where you wanted them before you turned them on, making it so you didn't have to fight them as much. Here you can see some of the lengths that we went to position the steel and clamp it in place. If you don't get it positioned properly when you start welding, it's not going to be right. Again, another example where we're using these switch magnets, which are so much easier to use than the standard magnets. You may have picked up in the video that there's some red dust at the foot of the grinder. That's the cheap sandpaper I bought on Amazon. It's supposed to be ceramic sandpaper, but it is not good quality sandpaper. In the horizontal position, the piece of steel wants to pull the piece to the right. So you probably want to use more of a dragging action here so it doesn't catch like you see in the video there. Alright, so I'm going to give you a quick tutorial, I guess, on the moving parts of this belt grinder. So over here, this lever, this adjusts the height of the tool rest. This lever here, that adjusts the positioning in and out with the tool rest. So if you don't want that notch, especially if you have the belt grinder in the horizontal position, you can flip that around. No notch there. The belt grinder, just to remove the belt, press down on this lever here. That comes off nice and easy like that. It goes on just as easily. What I've done, especially if you don't have variable speed, is just run this thing by hand so you'll see how it tracks, because this here, so turning it to the right makes the belt track to me. Turn it to the left and it makes the belt track away. And a little bit goes a long way there. To tilt the belt grinder, I'm going to step around the other side. You simply loosen, got that pretty tight, this lever here. And the weight of the motor actually wants to bring it
down. And all of these are repositionable. So if you want to make it tighter or you need the lever in a different position, you just pull out and rotate and then tighten. With this in that position, you will see how the tool rest can go up to the pad. You can have a gap, but you want it minimal. So you can do horizontal grinding, especially if you have a longer edge. That I find that to be very useful there. All right, and actually in this posture, you can see this arm and how it is affected. So this can move in and out. And I probably actually had that a hair tight. So you can even, if you don't want to grind the whole surface, you can actually have this below the work surface. I think that's somewhat of a rarity. Most times I think you're going to be in front of, not below it. So seemingly a very nice design. The only thing that I find a little bit weird is the pivoting function. So the weight of the machine and in this case just holding on to the motor seemed to be fine, but you just kind of have to be cognizant of, as soon as you loosen that, this is going to want to swing down. I've not used this machine a lot, but I have used it a bit, and so far, very happy with it. So here we are at the back side of the machine. This one area here is probably the one complaint that I have with this design, and it's probably not avoidable, but if you see that worn paint there, although at this point it's kind of in a nice arc, and then in that area there between those pieces of metal where the paint is going to get all chewed up, the only way around that probably would have been to tape it off and just lubricate it rather than painting it. But as a painted edge, it's definitely going to be a little chewed up. In the video, the previous video, you saw some janky switch dangling off the motor. We've kind of improved that. It's not my final solution, but it's better than what it was. I'm going to have a 3-phase motor on there with a variable frequency drive, so that won't even be in the equation at all at this point. At that point, excuse me. So my closing thoughts on this project are this. This is not an easy project for the novice. I didn't really have a difficult time working with an experienced fabricator, but I couldn't really say how it would turn out without his help. So big thanks to Tom the Welder.
well-designed project. Jared did a great job. I really can't complain about anything. You know, there's some spots where some paint's wearing that you would like it to not wear, but it's probably not practical for that paint to not wear in those spots. The solution would be to not paint there and just keep it lubricated so it doesn't rust. But, you know, working awesome in the upright position, horizontal position, and you know, I'm impressed. He did a great job designing this. I would highly recommend it to you, and you know, especially if you have a little bit more experience, you know, take your time and in positioning your pieces, because once you get them welded, of course you can cut them apart, but you know, it'd be a pain in the neck if you really welded it solid and found out something didn't work. So really take your time in setting things up. Tom and I probably had close to 30 hours. You know, keep in mind we're fooling with a camera, and you know, as a novice, Tom's giving me pointers. He could probably work faster by himself than he could with the rookie that I am. So hope you guys found this video useful. Please like the video, and if you enjoy the channel, please subscribe. Hope to see you next time.